Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about classification of control systems. This is lecture series on linear control systems, lecture number 2. So our topic's name, classification of control systems. Overview. First point, classification of control systems. Next, natural control systems, man-made control systems, open loop control systems, closed loop control systems, manual and automatic control systems, linear and non-linear control systems, time varying and time invariant control systems, combinational control systems, analog control systems and digital control systems, MIMO and SISO control systems. MIMO means multi-input, multi-output and single input, single output control systems, deterministic and stochastic control systems, lumped and distributed parameters control systems, feedback control systems, process control systems, regulator control systems, servomechanism and LTI control systems. LTI control systems are very important. So our overview, this is our overview. And next, classification of control systems. What is the classification? First, control systems mainly two types. Number one, open loop control systems, and number two, closed loop control systems. Again, closed loop control systems also two types, manual control systems and next automatic control systems. Automatic control systems, again, pneumatic control systems, electrical control systems, electronic control systems, electro-pneumatic control systems and hydraulic control systems. Next, electronic control systems, again, analog control systems and digital control systems. So electronic control system two types, analog control systems and digital control systems. Digital control systems also microprocessor based control systems, PLC based control systems, programmable logic control. This means programmable logic control based control systems, and DDC based control systems, DCS based control systems and fuzzy logic based control systems. So what is DDC? DDC means direct digital control. This is the direct digital control. And DCS means distributed control systems. Distributed control systems. So this is our classification of control systems. First classification of the control systems. And second classification of control system, that means another classification of control systems. Again, control system two types. This is natural control systems and second, man-made control systems. Man-made control systems, again, manual control systems and second, automatic control systems. Automatic control systems, again, open loop control systems and closed loop control systems. So automatic control systems, two types, open loop control systems and closed loop control systems. Again, open loop control systems, again, two types, nonlinear control systems and linear control systems. Closed loop control systems also two types, nonlinear control systems and linear control systems. Nonlinear control systems also two types, time variant control systems and time invariant control systems. Linear control systems also two types. This is time variant control systems and time invariant control systems. So another classification of the control system. This is the importance, natural control systems and man-made control systems, and others what automatic control system. This is also very important. And automatic control systems also open loop control systems and closed loop control systems or feedback control systems. So classification of control systems. Another classification of control systems based on some parameters, we can classify the control system into the following ways. So natural control systems. What is natural control systems? The systems inside a human being or a biological systems are known as natural control systems. So this is the very important terms, human being or biological systems. This type of control system is called natural control systems. An example of this kind of control systems are universe control systems and human body control systems. Another control systems, man-made control systems. Many control systems that are prepared or developed by man are known as man-made control systems. So this is developed by man. That's why this type of control system is called man-made control systems. This is the very important and example of these control systems, vehicles type control systems and aeroplane control systems, etc. So natural control systems and man-made control systems. Again, what is open loop control systems? Open loop means no feedback path, just input corresponding output. So what is open loop control systems? The control technique in which the calculated or estimated amount of energy is supplied to a process plant according to the practical experience of an operator in order to maintain a process variable at the desired value without receiving any feedback information about the actual value of the variable in the process plant. So this is the without receiving any feedback information. This is the very important, without feedback. That's why this type of control system is called open loop control systems. What is the example of open loop control systems? Control of temperature in a room. In a room temperature, this is the example of open loop control system by adjusting coal or fuel flow to the furnace of the steam generation by an experienced operator. So this is our example, room temperature by experienced operator and used coal and fuel flow. So next block diagram for open loop control systems. First block, coal supplied by the experienced operator according to deviation of room temperature from desired value. So coal supplied by experienced operator. This is the very important also, by experienced operator, because in this case no feedback, only ideally coal supplied by an experienced operator. Suppose our room temperature, required room temperature 25 degrees centigrade. So experienced operator supply the coal for 25 degree centigrade. And next block, furnace or heating systems. So coal burn and boil the water, boiler drum. So this is the boiler section, and boiler section controlled by water, boiler water control, and storage steam unit. This is the storage steam unit, and steam flow. This is the room, our required room temperature. Suppose 25 degrees centigrade. This is our 25 degree centigrade required room temperature, 25 degree centigrade. So this is our room being heated, but no information. This is ultimate 25 degrees centigrade, 24 degrees centigrade, or 26 degrees centigrade, because no feedback in between input and output section. No feedback information. That's why this type of control systems is called open loop control systems. and this is the exhaust steam. So experienced operator supply the coal, and furnace burn the coal, and boiler produce the steam, and this is the steam storage unit, and this steam room being heated, and this is the open loop example. And closed loop control systems. What is closed loop control systems? Closed loop control systems means feedback presence. That's why this type of control system is closed loop. It is that closed loop control technique in which a process variable in a process plant is maintained at the desired value by adjusting fuel or energy flow to the plant according to the feedback information received from the plant about the actual value of the control variable and its deviation from desired value. So this is the very important according to the feedback information. This is required for closed loop systems. This is the feedback information. This is the feedback information. And what is the example? Closed loop control systems, mainly two types: manual closed loop control systems and automatic closed loop control systems. Manual closed loop control systems and automatic closed loop control system. This is the practical examples. What is the block diagram? This is the reference input or set point. This is the reference input or set point. And this is comparator or summing point or regulator. And this is error signal. Error signal means this is equals to reference input minus feedback signal. Reference input minus feedback signal. This signal minus this signal. And this is the amplifier. Amplifier output controlled by controller, and controller output signal control the exact plant or process. So this is the very important also, because controller section control the plant. So this signal ultimate control the process or plant section, and process output or plant output ultimate controlled output signal. And this is the feedback path. This is the feedback path. This path, this is the feedback path. Feedback may be positive, may be negative. Feedback may be positive, may be negative. So output by input, controlled output divided by controlled input is called efficiency of the system or transfer function of the system if all initial conditions are zeros. And this efficiency always less than 1. If 90 above 98%, this is the perfect systems or efficiency high systems. So practical examples of closed loop control systems. What is the practical example? Automatic electric iron, water level control, servo voltage stabilizer and air conditioner, cooling system in car, missile launch and auto tracked by radar. This is our example of the closed loop control systems. Then manual closed loop control systems. What is the manual closed loop control system? This is also important because it is that closed loop control technique in which a process variable in a process plant is maintained at the desired value by adjusting fuel or energy flow to the plant with the help of an experienced operator according to the deviation of the process variable from desired value. So this is controlled by experienced operator according to the deviation of the process variable. This is the important sentence. So this is controlled by the experienced operator. That's why this type of control system is called manual closed loop control systems. So what is the example? Manual closed loop controls of temperature of a room by adjusting steam flow by an operator. So room temperature control, this is also manual closed loop control system. What is the block diagram? Again, this is the first block, coal supplied by the experienced operator according to deviation of room temperature from desired value. So experience operator, cold supplied on the furnace. So this is the furnace and or heating systems. So coal burn, and this is the boiler section, and boiler section controlled by water, and this generated steam storage unit. This is the steam storage unit, and this steam storage unit control the room temperature. This is our room. Suppose again our required temperature 25 degree centigrade. Our required temperature 25 degrees centigrade. Suppose this is required 25 degree centigrade. Then steam flow, after steam flow, room being heated, and this temperature 25 degree or less than 25 degree or greater than 25 degree. So telephone operator sending information about the actual temperature of room. This is the telephone operator sending the information, the exact temperature of the room, and vice versa. So this is this section, exhaust steam section. So this is our closed loop control system, because experience operator supplied the cold, and this cold burn on the furnace, in the furnace, and this is the boiler section controlled by water, and this steam storage, the steam storage unit, and this steam control the room, and room being heated, and this information sending by an experienced operator. This is the experienced operator section, and this is the exhaust steam. This section exhaust steam actually. This is the exhaust steam. So this is our closed loop manual control systems examples. And then automatic closed loop control systems. What is automatic closed loop control systems? It is that closed loop control technique in which a process variable in a process plant is maintained at the desired value by automatically adjusting the fuel or energy flow to the plant without any human help. So in this case, no human helps, only automatically controlled by automatic controller. So this type of control system is called automatic control system. So this is the block diagram. This is the block diagram for automatic closed loop control systems. This is the reference input and set point or desired value. This reference input may be step, ramp, parabolic, impulse, sinusoidal, discrete, analog, any type of input you can apply. And this section, comparator section or summing point, and this is the error signal. Error signal means reference input minus feedback input. This signals ultimate input of the control unit, and control unit output signal, actuator input signal. Actuator output signal, signal converter, and this signal converter ultimate for automatic control. This is the auto systems. This is the auto system. If this is the manual, then used by or controlled by manual station. So in this section, this is the auto section. And final control element, this is the final control element. That means this is the exact value for plant or process input magnitude. This is the process or plant, and after operation, this is the output, and this output feedback, and this feedback signal detector and amplifier unit or sensor. This is the negative feedback system. This is the negative feedback systems, and output by input is called the efficiency. If transfer function definition, then output by input is called transfer function if all initial conditions are zeros. So this is the block diagram representation of automatic closed loop control systems. Again, according to the method of analysis and design, the control systems are classified as linear and nonlinear control system. This is the very important in our life, because what is linear systems or what is nonlinear system, this basic idea required for every engineering students. So linear control systems. What is linear systems? A control system is called linear if it satisfies the additive property as well as homogeneous properties. So if satisfied additive properties and homogeneous properties, then this type of control system is called linear control systems. This type of control system is called linear control system. So what is additive property? Suppose if x, y, and z be the domain of the function f, function of x plus y plus z, then we can write f of x plus y plus z equivalent to or equals to fx plus fy plus f of z. This is the additive property. And what is the homogeneity property? A system is said to be homogeneous if we multiply input with some constant k, then the output will also be multiplied by the same value of constant k. Suppose f of kx, this k multiplied into x. So the output k into function of x, output k into function of x. This type of properties is called homogeneous property. Homogeneity property, homogeneous property. Example of linear control systems are a purely resistive network with a constant DC source, because this circuit follows the principle of additive properties and homogeneous properties. If all the undesired effects are neglected and we get the linear voltage and current. So this is the example of linear control systems. Then what is nonlinear control systems? A control system is called nonlinear if it does not satisfy the additive property as well as homogeneous property. So nonlinear control systems not satisfied the additive properties and homogeneous. That means does not satisfy the superposition formula. So this is our nonlinear control systems. Example of this kind of control systems are thermostat controlled heating systems, on-off control systems, saturation control systems, dead zone control systems, hysteresis control systems, backlash control systems. These are all nonlinear control systems examples. Some properties of nonlinear control systems examples are they do not follow the principle of linearity and homogeneity. That means superposition formula do not follow the superposition formula or linearity and homogeneity. They may have numerous isolated equilibrium point. This is the very important for numerous isolated equilibrium point. They demonstrate the properties such as limit cycle. This is also important, limit cycle. And the solution of the nonlinear system may not exist for all times. And this is also important points. Another classification of the control system according to the objective control. Another classification according to the objective control. What is the classification? Single input and single output control systems. If a control system has one input, if a control system, suppose this is our control systems, and this control systems just only one input and only one output. So this type of control system is called single input, single output control systems. Single input, single output control systems. Example of this kind of control systems: temperature control, position control, etc. So multi-input, multi-output means if a control system has multiple input and multiple output, then the control systems is called multi-input, multi-output control system. That means n number input, n number output. This type of control system is called multi-input, multi-output systems. Example of this kind of control systems, PLC type systems or programmable logic control systems. Example of this type of control systems. So another classification, time varying and time invariant control systems. What is the time variant control systems? or time varying control systems, and what is time invariant control systems. If the parameters of a control system vary with time, again, if the parameters of a control system vary with time, the control system is termed as time varying control systems. And if the parameters of a control system do not vary with time, it is the term as time invariant control system. So if the control system do not vary with time, then this is called time invariant control systems. According to this type of signal used in systems, reference is often made to continuous data control systems and discrete data control systems, or modulated and unmodulated control systems. So continuous time and discrete time control system. This is also important. What is the continuous time control systems and what is the discrete time control systems? Based on the type of the signal, the control system can be classified as continuous time control systems and discrete time control systems. When all the signals are continuous in time, this type of control system is called continuous time control systems. Again, when all the signals are continuous in time, this type of control systems is called continuous time control systems. On the other hand, in discrete time control systems, there exist one or more discrete time signals. This is the very important part. So what is continuous time and discrete time control systems? Then combinational control systems. This is also important because the mixture of natural control systems and man-made control systems is called combinational control systems. This is the mixture of natural control systems, and man-made control systems is called combinational control systems. Example, what is the combinational control system example? The combinational control systems is an example, driver driving a car. This is the very beautiful example because driver driving a car, this is natural and man-made mixture control systems. Then optimal control systems or industrial control systems. And optimal control is a set of differential equations describing the paths of a control variables that search for a best possible control parameters with respect to a preference matrix and minimize the cost function. This is the minimize the cost function. That's why this is the research control system, also called the research control systems. Objective function, cost function. Optimal control systems. Another classification of control systems are according to the objective of control. What is the name? Regulator control systems. In presence of disturbance, the controlled output value always maintained the constant or stable. It is a system or arrangement in which there is a constant steady state value for a constant input signal. This type of control system is called regulator control systems. Then what is the servomechanism? What is the servomechanism? A servomechanism is power amplifying feedback control system. So this is the power amplifying feedback control system. This is the power amplifying feedback control systems in which the control variable or the output is a mechanical position or its time derivation such as velocity or acceleration. This type of control systems is called servomechanism control systems. So this is the power amplifying feedback control systems and mechanical position or its time derivation such velocity or acceleration. This type of control system is called servomechanism. And digital control system. This is the modern control systems or smart control systems, because if one or more system variable of a control system at certain discrete time, discrete signals or signal may be in the form of pulse. It is termed as discrete time control system. So if pulse or discrete signal presence, so this type of control system is called discrete control system. This type of systems can handle linear and non-linear both cases. This type of control system handle linear control systems, also non-linear control system. So this is the multi-talented control systems. In these systems, the requirement of the power is less, accuracy is high, reliability of the digital systems is high. Digital control system is used in computer systems. This is logical operation system which increases their performance. In case of discrete type systems, the loss are minimum. So this is the advantage, or this is the properties of the digital control systems. Then analog control system. What is analog control system? That means continuous control systems. When the input signals of a system is continuous, the control system is called analog control systems. When the input signal of a system is continuous, the control system is called analog control systems. In this system, the signal are the continuous function of time, continuous function of time. This type of control system is called analog control systems. Continuous input signal like sinusoidal type signal, square type or single input source, continuous triangular form. This is an example of the analog control systems. Then active control systems and passive control system. And previously, this is actually deterministic and stochastic control system. This is also very important section. If the response to input and the external disturbance of a control system is not predictable and repetitive, the control system is said to be stochastic control systems. And lumped and distributed parameter control system. This is practical example, inductor, capacitor, resistor. And if a control systems can be represented by ordinary differential equations, it is called lumped parameter control systems. In these control systems consist various active parameters, inductors, capacitor, and passive parameters, resistors are used, and all the parameters distributed uniformly along with the length. This is also very important systems. All the parameters distributed uniformly along with the length. This type of control systems are called distributed parameter types of control systems. So this is also called lumped and distributed parameter control systems. And feedback control system, this is actually closed loop control systems. So a feedback control systems is a systems where the output is feedback to the input and whose output is controlled by its measurement as a feedback signal. This feedback signal is evaluated with the reference signal to produce an error signal which is filtered by a proper controller to produce the system's control unit. A control systems are usually negative feedback systems. The oscillation are the example of the positive feedback. This is the very important. Oscillation are the examples of the positive feedback. In general, we can maximum case use the negative feedback system, and the positive feedback example oscillation are the example of the positive feedback control systems. So this is our block diagram for feedback control system. This is negative feedback control system. This is the reference input or set point. This is comparator or summing point. This is error signal. Error signal means difference between input signals and feedback signal. This is the control input, control input output signal. actually actuator input signal, and actuator output signal, plant or process input signal. So this signal very important, because if this is the uncontrolled signal or this is the disturbing signal, then plant output or process output also not accurate. That's why this is very important. And output feedback, this is the output section, overall output, and this is the feedback path, and this is sensor, and output by input is called efficiency or transfer function if all initial conditions are zeros. So example of this kind of control systems, example of positive feedback systems are electronic amplifier based on an operational amplifier or op-amp. Example of negative feedback control systems are in automatic electric iron, water level control, temperature control, and voltage stabilizer, etc., etc. This is the example of feedback control system. So next, process control systems. What is the process control systems? The technique by which a process variable in a process plant is maintained at the desired variable in order to obtain better quality product at lesser cost with a better safety of operation is called the process control. This is actually industrial control. So cost minimization essential or less cost. So this is the again definition, the technique by which a process variable in a process plant is maintained at the desired variable in order to obtain better quality product. This is also important, better quality product at lesser cost. That means low cost but high efficiency or quality, better quality of output. So this type of control system is called process control systems. And automatic control systems in which the output is a variable such as temperature, pressure, flow, liquid level, or pH is called a process control systems. So this is also this term, temperature, pressure, flow, liquid level, pH is called process control system. Then linear time invariant control systems. What is LTI control systems? This is our control systems classification. Control system mainly two types: natural control systems, example human body, and man-made control system, example vehicle, aeroplane, etc. And man-made control systems also two types. Number one, manual control systems. Number two, automatic control systems. Manual control system, example fan, regulator, and automatic control systems, automatic electric iron. Automatic control systems also two types: open loop control systems, already discussed, traffic signal, and closed loop control systems, missile. And open loop control system also two types: linear control systems and non-linear control systems. Example, purely resistive network with constant DC. This is the linear control systems example. And linear control systems also two types: time variant control systems, time invariant control systems, and non-linear control systems. Example, on-off control system, saturation, dead zone, hysteresis, backlash. And this control systems also two types: time variant control systems and time invariant control systems. And this block is very important because man-made control systems, automatic control systems, closed loop control systems, non-linear control systems, time invariant control systems, these are all LTI control systems or linear time invariant control systems. So this section is the linear time invariant control system. This is the linear time invariant control systems. These are all linear time invariant control systems. So thank you.